We will solve one more problem. Here again, find the number of pages and number of frames for the following. Logical address is given 32 bits, physical address 24 bit, and page size 2 KB. So in the previous problem, we have seen that to get a main memory size, we are going to use this. To get a secondary memory size, we are going to use physical address, and to get D, we are going to use this page size. Okay, just to uh, you can just remember this and you can solve the problems very well. Okay, very easy to solve. So we assume that it's a byte addressable memory, main memory. So what will be the page size? Page size is 2 KB given. So you will get that as 2 KB upon byte addressable, right? So we have already seen this. So you will get 2K, that is equal to 2 into 2 raised to 10. Okay, so that is equal to 2 raised to 11. Okay, so now what is this 2 raised to 11? 2 raised to 11 is D. Okay, so D is equal to 11 bytes, 11 bits. Okay, 11 bits. So what is logical address given? Logical address is given as P and D, and what total number of bits? 33 bits. So 33 bits are given. So this 33 bits, and now I know what is D. D is 11 bits, so I can write this is 11 bits here, 11B, and how much remaining? 22. Okay, so from this, as we have already done in the previous problem, we can find out the base size is 2 raised to 22 is equal to 2 raised to 2, 2 raised to 20 equal to 4 mega. Okay, then we can have the secondary memory size that is equal to 33 bits, that I can write as 2 raised to 3, 2 raised to 30. So this will be 8G into 1 byte of memory. Okay, so that will be 8 GB. So this is the size of secondary memory required. Okay, now for physical address, again it has two parts, frame and D. Now you know what is D. Okay, what is the total size given for physical address? It is 24 bits. Okay, so D is 11. So 24 minus 11 is 13. Okay, so from this we'll get the size of the frames, number of frames, 2 raised to 13. We can write as 2 raised to 3 into 2 raised to 10. That will be equal to 8K. Okay, what is the size of main memory? We'll get it from here. So we can write as 2 raised to 24 equal to 2 raised to 4 dot 2 raised to 20, that is equal to 16M into 1 byte. So we'll get 16 MB. Right? So this is how we can solve the problem.